You're welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 5 from the May-June 2018 Pure Mathematics P1 paper. This is paper 1 variant 1 from the Cambridge 9709 syllabus. This is a question which is related to straight line graphs, and it's question number 4 from my P1 end of topic worksheet number 3, which is about straight line graphs. And here we have a question where we're told that the diagram shows a kite. Okay, so we have to remember some of the properties of these special quadrilaterals that we learnt in IGCSE. It's very important for us to know those properties that will help us in answering such questions as these, in which AC is a line of symmetry. Okay, it's like a diagonal of the kite, a line of symmetry. All right, and the coordinates of A and C are given 0, 4 and 8, 0 respectively, and O is the origin. They've told us to find the equations of the line AC and the line OB. So the line OB would be a line that connects O and B, and we can see from this diagram that this line OB is basically the other diagonal of this kite. Okay, so for us to find the equation of AC is no problem, because we have 2 points on the line. Okay, we have the point A and C. We can find the equation of a straight line, we need 2 pieces of information. To find the equation of a straight line, we need the gradient of the line. Okay, the gradient of the line, which we call M, which we can find because we have 2 points on the line. Change in y over change in x. And the second thing we need is any point on the line. Okay, and if we have the y-intercept, even better. Okay, so we have the point A, which is the y-intercept of this line AC. So any point on the line, the x and y coordinate, if we have the y-intercept, that's even better, as we will see. So to find the equation of this line, okay, AC, so let's start with AC. We first need the gradient of AC. Now the gradient of the line AC is going to be given by the change in y over the change in x. So if we see the change in y is going to be 4 minus 0, doesn't matter which one you start with, 4 minus 0 over, and then the change in x, 0 minus 8. So if I start with this coordinate, I must start for the y, I must start with the same one for the x. But it must be what change in y over change in x. Okay, y1 minus y2 over x1 minus x2. You can call it y2 minus y1 over x2 minus y1 if you want, as you wish, no problem. Okay, it doesn't matter which way. If I did 0 minus 4 over 8 minus 0, that would also be fine. You would still get the same answer, but it must be y over x, change in y over change in x. In this case, it's 4 over negative 8, which is going to give you negative a half. And you see, if we did it the other way around, we would have got 0 minus 4 over 8 minus 0, which would also be negative a half. It would be negative 4 over 8, which is negative a half. So we have the gradient of AC, and because we know that this line passes through 4 on the y-axis, we can just use the general form. We know that C is equal to 4 because the coordinates of the point A, 0, 4, if the x coordinate is 0, then this must be the y-intercept, because on the y-axis. So we can just straight away say y equals mx plus c. So therefore we can say y is equal to negative a half x plus 4. Now they didn't state in which form we should write the equation. We can leave it like this, and that's probably better in this case because it's like, pretty easy. If you want to, sometimes they might say express it in the form ax plus by plus c equals 0, where a, b, and c are integers, in which case you'd have to get rid of the fraction, and you'd write this as, this is in case they ask you that, just to show you, 2y is equal to minus x plus 8. Remember, multiply the whole thing by 2, and then we can say x plus 2y minus 8 equals 0. So this is the same equation as that, just written in a different form. So there's the answer to the first part of question 1. We also have to find the equation of the line OB. Now for us to find the equation of the line OB, we have to understand a few things. First of all, we need a point on the line, which we have. So we need to find the gradient, which I'll discuss in a minute. We have to find the gradient of OB, and we have to have a point on the line. Well, we have the origin. So 0, 0, that means C is going to equal 0 here in this case. So what is the gradient of this line? Well, what we have to understand is from the properties of a kite, is that the diagonals, okay, they intersect at 90 degrees. So this angle here is 90 degrees, which means OB and AC are perpendicular. So we can say that for the gradient of OB, okay, is, or we can say OB is perpendicular to, OB is perpendicular to AB. Okay, OB is perpendicular, sorry, to AC, not AB. Okay, it's perpendicular to AC. Therefore, the gradient of OB is going to be the negative reciprocal. So it's going to be, we know the gradient of AC is equal to negative a half. We take this, we change its sign, and we turn it upside down. So we write it as a reciprocal. So negative reciprocal becomes positive, and 2 over 1, which is 2. So we know the gradient is equal to 2, and we know that it goes to the point 0 on the y-axis. So very simply, if we use y equals mx plus c, then y is equal to 2x. So that's the equation of the line, okay, OB. So that's for OB, and this is for, that was AC, okay. So there we have found the equation of the two lines. Okay, so there's part 1 done. Now for part 2. Okay, so part B, it tells us to find by calculation the coordinates of point B. Okay, so part 2, find the coordinates of point B. Now we just found that this line is y equals negative a half x plus 4. And this line has equation y equals 2x. Okay, so we found those pieces of information. Now, to find the coordinates of the point B, what we can do here is the following. We have to understand that this is a kite. A, B, C, O is a kite. Okay, let me just draw some lines in there to make it very clear that we have a kite here. So this is A, B, C, O. This is a kite. Okay, now in a kite, the diagonals, we should know the properties of the kite, and the diagonals, they intersect at right angles, and the longer diagonal bisects the shorter diagonal. So the longer diagonal cuts this one into 2 equal halves. So this point here, I'm going to call it M. This point here is the midpoint between O and B. And we know O has coordinates, of course, 0, 0. So if we can find the coordinates of B, okay, sorry, if we can find the coordinates of M, we can then find the coordinates of B. Okay, because we can find the coordinates of M, why? Because we know the equation of these two lines. We know the equation of AC and OB. So M is where we can say that the line OB and AC intersect. Okay, so we can find that point M, okay, by using simultaneous equations. And once we know the coordinates of the point M, we can work out the coordinates of B because it's the midpoint of OB, as we'll explain. All right, so first step is to find the coordinates of M. Okay, so we have y equals 2x and y equals negative a half x plus 4. So if we want to solve these simultaneously, we can take equation 1 and substitute it into equation 2. I can replace the y with 2x. We know y is equal to 2x. Okay, so I'm replacing this y with 2x. That's how I like to think about simultaneous equations. So you have 2x equals a minus half x plus 4. This is the equation now. When we solve it, we'll find the x coordinate of where these two lines intersect, which is the point M. Okay, so we can, if we want to get rid of the fraction, we can get rid of the fraction. Okay, we can multiply everything by 2, or we could just add a half x to both sides. That will give us, 5 over 2x, because this will be 2x, which is going to be 4 over 2x, plus 1 over 2x, which is 5 over 2x, okay, equals 4. So x equals multiply by 2 and divide by 5. So you're going to have 4 times 2 over 5. So x is going to be 8 over 5. As I said, alternatively, what we could have done here is we could have multiplied everything by 2, in which case we got 4x equals minus x plus 8. And then we end up with 5x equals 8. X equals 8 over 5. That's an alternative way of doing it. So once we have the x value, we can find the y value very easily. Y is equal to 2x. Therefore, we know that x is equal to 8 over 5. So y is equal to 2 times 8 over 5, which is 16 over 5. Okay, so that's, let me just, okay, so we have the coordinates of the point M are 8 over 5 for the x coordinate and 16 over 5 for the y coordinate. So now we need to find the coordinates of B. Okay, so we have basically O, which has coordinates 0, 0. We have the midpoint M, which has coordinates 8 over 5 and 16 over 5. And we have the coordinates of B, which I'll call XB and YB. So there's a couple of ways we could work out how to find the x coordinate of B and the y coordinate of B. Basically, we know that this is the average of the x coordinates. So I can say that 0 plus xb divided by 2 is going to be 8 over 5. Okay, and for the y coordinates, I can say that 0 plus yb, the midpoint is the average of the x coordinates. So you have x1 plus x2 over 2 and y1 plus y2 over 2. That's how you find the midpoint. So we know the midpoint is 8 over 5. So I know that this is equal to, the two x coordinates added together divided by 2. That's what we've done here. And I know that this is equal to the two y coordinates together, which is 0 plus yb over 2 is going to give me 16 over 5. Okay, so we can find what xb is and what yb is. Multiply by 2, so xb is going to be 16 over 5 and yb is going to be 32 over 5. Okay, so those will be the x and y coordinates. If you want to write them as a mixed number, 16 over 5, 5 goes into 16 3 times, remainder 1, so that's going to be 3 1/5. And this is 32 divided by 5. 5 goes into 36 times, remainder 2, so 6 2/5. We can write it like that. We can leave it in this form, but that is the point B. That is the point B. M is a midpoint of OB, so we can find B. Another way we can do it is basically using a visual method, that I know that this is the halfway between these 2 points. So how do I get from 0 to 8.5? 8 over 5, sorry, I add 8 over 5. So to get from there to there, I have to add another 8 over 5. Okay, and how do I get from 0 to 16 over 5? I have to add 16 over 5. So to get from there to there, I have to also add another 16 over 5. So whichever way you think about it, algebraically, visually, you end up with your answer for B. So there we have the answer to this question. I think that was everything to the question. Yep, that's the whole question. So I hope that was clear. One of the students was asking me about this question. So I've answered it. And remember, we need to recall some of the things that we learned in IGCSE. They're not specifically mentioned in the syllabus, nor given in any formula sheets, but some of the properties of the special quadrilaterals, like kites. You have to know that the diagonals bisect each other. Well, one diagonal bisects the other. The longer diagonal bisects the shorter diagonal, means it cuts it in half, and they intersect at right angles. You have to know that for you to be able to answer this question. So it's very important that you recall those rules. It's a good idea to revise them, especially before your exams. And the more questions you practice, the more of these type of situations you'll come across, and the better prepared you will be. Anyway, so that concludes this question. Other questions from this particular paper? if I answer any questions from this paper, if I'm requested to, it will be in the playlist over here in this top right corner of the screen. Other questions from this end of topic worksheet on straight line graphs you'll find in the playlist that will appear in the bottom right of the screen here at the end of the video. Other questions from straight line graphs in general of my P1 collection from Cambridge you can find over here. You can subscribe to my channel by clicking on this link, and there's a video that will show on the card on the top which will show you how to use my channel in order to find what you're looking for. Whichever examining board you're doing, you might find some of the content useful. Even IGCSE material is there. Okay, thank you for watching and see you soon.